In the previous video, we looked at the context of cloud and what does it mean to create cloud native applications. We didn't define that at that time, but we looked at how cloud native has made the task of creating software, which is massively scalable, right, and has very good properties associated with helping companies grow from startup stage all the way to very mature stage without having to change much. That became very attractive, right? So that was the context of how cloud native came into play. So in this video, we will look at what cloud native itself is formally. We will also look at how cloud has made services accessible for writers of cloud native software, and what do those services mean, what do they abstract, what do they simplify, what do they make more complex. So let's start with the definition of cloud native. There is actually a very specific definition which is important to understand. So cloud native is a design principle for software which enables loosely coupled systems that are resilient, manageable and observable. So loosely coupled is underlined here because it is basically the way that which cloud is best used, right? So again, go back to that context of cloud. We started off by saying appliances which were specialized and highly customized and built for a specific task were also the ones which were expensive to build in the first place and expensive to maintain, and the know-how associated with it was concentrated in the hands of only few people, few companies. Whereas the opposite is what you need typically, right, as a company, which is I want as many people as possible to be able to help me out in case I'm stuck somewhere. I want as much optionality in terms of types of vendors to work with, the types of software to do my work with, to get the same thing done. And those are possible only if I design my system which is not like a monolith, right? I design my system in a way that's truly loosely coupled, so that I can pick and choose which one of those subsystems within those systems I can just replace with anything else of my choice, be it for financial reasons, be it for technical reasons or anything else. So loosely coupled systems becomes the operating model for how cloud gets used best, because you can pick and choose, like I said, which ones you want, but also you want to be able to have the guarantee that if I replace one specific subsystem here, something else will not fail, right? That's what loosely coupled means. Whereas a tightly coupled system, like one of those appliances that we spoke about, if I change one lever, let's say the lever that's responsible for dispensing cash, if I change one nut associated with the lever, I have to probably go back and calibrate a whole bunch of settings in my software, right? So that's an example of a tightly coupled system. Alright, so loosely coupled systems, cloud native software, cloud native design principle enable loosely coupled systems, and those loosely coupled systems are characterized by what, right? They're characterized by three things. First is resilience, second is manageability, and third is observability, right? Three very, very important words. Resilience refers to the fact that am I withstanding failures, right? The failures could be hardware failures, could be software failures, meaning the software has bugs in it, as an example. Could be network failures, could be like CPU failures, etc., right? So the resilience comes from the fact that the software can pick up from where it left off, meaning it does not affect functionality. Failures do not affect functionality. That's what resilience refers to. Now, resilience is a property of a software, and with cloud native as the design principle, effectively we are now saying that if you design it with this principle, then you will get resilience, which is a very, very powerful statement to make, right? Now, second property of cloud native, of these loosely coupled systems which are built using cloud native, is that they become manageable. Now, this is a very simple term at its root, but it's got profound implications. So when you have loosely coupled systems, meaning when you have systems which have a lot of subsystems which have different moving parts, each subsystem has a mind of its own, so to speak, right? It has its own requirement with respect to interfaces, it has its own need for hardware, and it has its own ability to make use of that hardware. Now, if you have multiple such subsystems, how do you get around to understanding what is happening where, right? Now, understanding is necessary, because that's how you would know how you would tweak something, right? Or how you would run out of resources so that you can add more, or how you would monitor for health such that you know that something's failing and there are too many things failing, so you have to go back and order a fresh batch of machines or fresh batch of disks and so on. So once you do a loosely coupled system, once you put that into action, you need to be able to remotely assess all of these indicators, all of these signals, all of these data sets about how these things are functioning, and then once you assess it, then you need to be able to take action on top of it. So the ability to assess, the ability to understand what is happening where is what observability refers to. So meaning those subsystems which are part of that cloud native software, they provide data in order for you to observe what is happening within them, right? That's what observability refers to. So which means those systems are observable, and once you know what you're observing, once you observe it, and then once you interpret what you're observing, then you can start to take action on top of it. And that action taking comes back to the manageability, because it's not enough that you just observe that the health is failing in a cluster. If you're not able to take action on top of it, then the software could crash at a particular point in time, dramatically affecting business, right? So what you need to be able to do is not just observe, but also take action on top of it. So that manageability is a fundamental property. So if you put all three together, what you're effectively saying is the software is allowing you to observe what is happening, look at current performance, look at where things are failing, look at where things are going good, then take action on top of it, right? So that you can keep adjusting to newer scenarios of newer types of hardware, newer emergent threats related to security, related to failures, and then have the software automatically handle certain types of failures for you, so that you don't have to worry about mission critical workloads which are running on top of that software, right? So in a nutshell, with a system that's built using cloud native principles, you would have this loosely coupled system that we just spoke about, which has the ability to support a mission critical business, starting from as small a need to as large a need, with as small a footprint in terms of data processing capability to as big and as fast a footprint as necessary to cater to the massive amount of data that's coming in at very high velocity. So that's what the benefit is, right, of building a cloud native software. So to break it down further, the scale at which your business needs evolve can be catered to without changing anything related to the functional side of the software. So it doesn't matter the volume in terms of users, in terms of data, in terms of velocity, in terms of variety, all of that can be catered to, right? Requirements, as they change, can be constantly worked upon on the front end, right? Meaning on the functional side of the software, without changing anything on the back end, without changing anything on the hardware, without changing anything about the assumptions made about the type of memory and CPU and things like that, right? And as and when that change keeps getting made on the functional side, the non-functional side of the software can be automated completely with respect to packaging of the software, such that you can deploy what's called as continuous integration and continuous delivery, and constantly keep shipping newer pieces of software, newer versions of incrementally better software as the business requirements change, such that you can completely become data driven as a business. So let's take an example of what I mean by this. Let's say you're a startup, and as a startup, you're working with 1,000 users. And with 1,000 users who are your regular customers, you get feedback about your business. And let's assume that you've built your software using cloud native principles, right? Which means your software has two parts, the functional side and the non-functional side. The functional side caters to your business directly. So let's say your business is e-commerce. So the functional side allows those 1,000 users to place orders on your website, make the payment for it, and then track the orders, right, for the payments that are made. Now, the software behind the scenes is able to work with different types of cloud providers and scales gracefully. As the volume increases though, right, you go back and you constantly keep monitoring what is happening, and from 1,000 users, your startup becomes more popular, it becomes opened up to like 1 million users. At that particular point in time, you no longer can run on one server, you want 10 servers to run your stuff. Easy, because you've built it on cloud native, you just run it on 10 servers, there's no change that's required to your functional part of the software. But then, as you scale from 1,000 users to like 1 million users, you also notice that the way that you've designed your business program needs to change. So for instance, one of the things you change is you want to introduce loyalty because you want customers to repeat with you as a repeat shopper. So that's a change that's come in. That change has come in because you notice that the customers don't come in often. Like they make one transaction and they go away, they never come back again. So that's data that's being produced by your functional side of the software, and you analyze the data. You just said, okay, churn is too much, churn is too high, so I want to drive loyalty. So let me introduce loyalty as a program, loyalty program as a change to my software. So that's a change that has resulted in a new functionality to your software. And as part of the new functionality rollout, because the software is built cloud native, nothing about the backend needs to change for your existing features and functionalities like order taking, payments, and order tracking. But the new feature of loyalty management will have to have an associated functional and non-functional module, and that will need to be implemented. Now, as part of that implementation, you're shipping the entire software for the rest of the modules as well, right? Which means the order taking will also need to now change because it needs to produce some kind of a dependency for the loyalty management. Because for every time an order is placed by a loyal user, you want to keep some count of it, right, in your loyalty management system. So there is a change in your order taking engine, there's a change in the payment engine, there's a change in the order tracking engine potentially, right? So because for loyal customers, you might want to give real-time order tracking as opposed to for your non-loyal customers. For customers who don't sign up for your loyalty, you don't give real-time tracking. You want them to come to your website and track manually, right? As an example. So those changes for these existing modules can be easily made, and you can create a DevOps pipeline which will automatically set up the testing of that software, of those functionalities, so that you know for a fact that the rest of the functionalities are not changing, right? So with that in play, as you roll out the changes, as you tweak some changes here and there, when you scale from 1,000 to 1 million, the backend just works. The new changes are rolled out with the full guarantee that none of the existing functionalities are getting affected, and newer functionalities are constantly being worked on by data analysis, right? As data gets analyzed, the business changes get propagated to the software easily, and the automation that the rollout of the software allows you to, not have to worry about taking down the production. You can just directly deploy software live and then get up and running and scale up. So what I just talked about is the ideal startup, and that ideal startup is fundamentally empowered by cloud native as a design principle. Now imagine if you didn't do any of this using cloud native, right? If your software is not architected using cloud native, instead you built one monolithic software. That monolithic software was running on a hardware which could be on the cloud, which may not be on the cloud, doesn't matter, right? Let's assume it's on the cloud for simplicity purposes. So that monolithic software was running on the cloud. That monolithic software had in its one module, one design, all of order taking, payments, and order tracking in one piece of software. Now, it wasn't designed using cloud native, so it had no attention to detail about fault tolerance or manageability or observability, which meant it produced no data about how it worked. It was not easy to change, right? You could not just deploy it on multiple machines or anything like that, and it was not designed for fault tolerance, which means every time there was a failure, somebody needed to go manually and change and deploy a new copy of the software, whatever, right, to make it to get it back up and running. So the kind of headache that you had to manage will be significant for fault tolerance purposes by itself. But even if you set that aside, if you just looked at the scale angle, right? So when you went from 1,000 to 1 million users, as you scaled without even having to have new functionality, you had to go and react to circumstances, because the software was not observable, which meant you had to go look at what is the current performance of the software. As the scale ramped up, as new users signed on, you would start to find that some of your responses were becoming slow. Order taking became slow. Payments used to take 2 seconds before, now it's taking 10 seconds. So you would then have to only resort to reacting to live degradations of performance, right? And by the time you know that the performance has degraded live, right, you are no longer able to react fast enough, right? So it takes a bit of time for you to react, because you have to go back and change the monolithic software. And when you change the monolithic software, you can't just touch one piece of code, right? You have to go touch a whole bunch of other parts of code in order to get it to scale better. Notice that I'm not even talking about that loyalty management change at all, right? That's a functional change. Here I'm just talking about change required to deal with newer scale, right? Because you didn't have that observability ahead of time, you didn't have that manageability, you didn't know how to act when the scale ramped up very quickly. And then finally, when you wanted to, when you figured out that loyalty was required, and then you introduced the loyalty program, you had to go back and change every single functionality, because it's all part of the same module, right? It's built as a monolith. And in doing so, you have to go test every single part of your functionality all over again, and then roll it out into production. And at that time, because it's not observable, you don't know whether your loyalty management, which is newly introduced, is going to scale to the level at which your existing modules have already been reactively adjusted to, right? So that's a whole new game altogether. So that is an example of a software which is going to not really serve the purposes of a fast-growing startup. It's going to be a nightmare to manage in reality. Now, in practice, no startup is going to have truly cloud-native software for all their different mission-critical systems from day one, right? Because that's just not functionally or practically feasible, right? It takes a lot of effort to build cloud-native software. But the good part is you would optimize and choose to put the efforts into those parts of your business which are mission critical and which are likely to scale, right? Which are likely to benefit from the cloud native principles, right? Basically scale. So in those kinds of scenarios, for those modules alone, engineering them as cloud native will result in a lot of benefits. And then over a period of time, as you take it up as an agenda, as an initiative, you could get all your rest of your systems also cloud native, and that way you clear up that technical debt. Great. So notice that throughout, I've been talking about it as cloud native software. I didn't talk about it as cloud software. There is a difference, right? Cloud software pertains to the software that's available on cloud, and which means in colloquial terms, it typically refers to the public cloud. Public cloud really refers to cloud provided by vendors such that the cloud is very easily accessible for people like you and me. We don't have to be companies. We just go directly consume it for our purposes, and we consume what we want. Right? We're not boxed into specialized software. So today there are a handful of public cloud providers who are extremely large in size and who have the scale, who have the complexity, and who have the capabilities to support whatever our needs are. Right? I'm talking about Amazon AWS, Microsoft Azure, Google GCP, Oracle, to a certain extent IBM and things like that, right? Vendors like this. Now, cloud software basically talks about software which is available on these clouds, but cloud native software is a design principle, right? A software that's designed using a design principle of cloud native. Which means that it could pertain to software which not necessarily runs on the cloud, right? You could run it within your data center. You could run it within your servers, within your desktop. More often than not, you will run it on some kind of a cloud vendor like Amazon or a public cloud vendor, basically. But you could choose to run it on your own servers. What matters though is the design of that software, which is cloud native, right? So that's why I'm making this distinction that public cloud is an enabler for cloud native, which means if you had cloud native software, you could use the public cloud to run it, and you would be able to do it very fast. Meaning you could get up to speed and have a live system much faster than like setting up your own racks and data centers and things like that. But public cloud is not a dependency. It's not a prerequisite. You could run cloud native software directly on even your desktops or even your laptops for that matter. I hope that's clear. Alright. So with that, I'll pause here. So next up, we will take a look at what are the different types of cloud services which are provided by public cloud. We will focus for the rest of the course on public cloud because that's easily accessible, it's cheap, and it's also got a lot of common shared knowledge which is accessible for all of us, right? So the skill sets are plenty, easy for us to pick up in terms of training courses and things like that.